Waffles are present by the simultaneous emergence of a Copenhagen wafer ice and wafer ice in the early Middle Age around the 9th until 10th centuries. In the late 14th centuries, the first known waffle recipe was penned in an anonymous manuscript, Le Ménager de Paris. This was a waffle or gouffre in name only, as the recipe contained no leavening. Not only were newly fashioned one rectangular, taking the form of the fire hostess, but some circular oblique areas were cut down to create rectangle. Good waffle from the Belgian was published as the first recipe to use leavening beer yeast. Germany became a leader in the development and publication of waffle recipe during the 18th century. At the same time, the French introduced whipped egg whites to waffle along with lemon zest, Spanish wine, and clove. Waffle recipe took on names to designate their country or region's city of origin. The 18th century is also when the word waffle first appeared in the English language. 1814, Anthony Biavilier published a recipe in Art de Cuisine when the brochette dough is introduced as the base of the waffle and the sacred case is used as the courage for the waffle. Stroopwafel Dutch syrup waffle rose to prominence in the Netherlands by the middle of the century. However, by the second half of the 8100, inexpensive beet sugar was widely available and a wide variety of pastries, candies, and chocolates were now available to our middle class, so waffle popularity rapidly declined. By the early 20th centuries, waffles were shifting from a predominantly straight batter-based product to an increasingly homemade product. Definition of waffle: when the pour between two hard, patent plates and waffle is a cake-like food made from leaf butter. Waffles are eaten all over the world and come in a variety of shapes and sizes. While waffles are traditionally served for breakfast, they can also be enjoyed as a snack or dessert. And then the ingredients for making waffle are flour, salt, white sugar, eggs, baking powder, warm milk, butter, vanilla extract, and yeast. After that, the types of the waffle are Belgian waffle, Brussels waffle, American waffle, and Liège waffle. Last but not least, the country that famous for making waffle are Belgium, United States, France, and Germany.
Hi, my name is Nisrina, and I will be presenting about the calculations of the waffle, including the volume of the waffle, the surface area of the waffle, and the spread needed. So for the picture used in our presentation, we didn't use the actual photos of the waffle because the photos that we took are blurry and it doesn't show the accurate representation of the measurements that we took. So we are forced to draw it, but don't worry. The measurements, the height, and the radius are accurate based on the waffle. So we're starting with volume of the waffle. For the volume of the waffle, we will use the formula of volume of cylinder, which is pi r square h. So because the h is equals to the thickness of the waffle. So the height of the waffle is 1.5 cm. And radius of the waffle is 9 cm, and we insert that measurements inside the formula and will be pi times 9 squared times 1.5, and the volume of waffle will equals to 381.7035 cm cube. We're moving on. Next, the surface area of the waffle. We will use the formula of cylinder with two bases, which is 2 pi r h plus 2 pi r squared. It's 2 pi r squared because there are two circles for the cylinder. So we use the height of 1.5 cm and the radius of 9 cm, and we will insert to the formula that will be 2 times pi times 9 times 1.5 plus 2 times pi times 9 squared, and we will get 27 pi plus 162 pi. And the surface area of the waffle will be equal to 593.761 cm squared. Moving on, next, to volume of cuboid. So the volume of cuboid, we will assume all the squares on the waffle are in the same size, the squares and the cuboids. So the width of the cuboid is 1 cm, the length of the cuboid is 1 cm, and the height is 0.5 cm. We will use the formula of volume to find the volume of each cuboid, which is width times length times height, and we will insert the measurements that we took inside the formula, which will be 1 times 1 times 0.5, and it will be equals to 0.5 cm cubed. So the total volume is 2 times 18 times 0.5. This is because we use 18 because for 1/4 of the waffle, 1/4 of the circle, there are 18 cuboids inside. And we times 2 because we only took 2 sides of the waffle, the semicircle, for the spread, because we search for the volume of cuboid to search for the volume of spread needed. So the spread will only be put on one side of the circle, which is semicircle. That's why we times 2. So the total volume for cuboids is 18 cm cubed. So next is volume of spread. So for the volume of spread, like I said, the volume of spread is equals to the volume of total cuboids on half of the waffle, which is the semicircle of the circle. So the assumption is we assume that the spread filled in those cuboids perfectly without any of it spreading outside of the cuboids. Which means if there's like a cuboid, the spread will be inserted perfectly inside. Like it doesn't have any spillage or any spreading outside of the cuboid, so it's perfectly inside. So the conclusion is if the volume of the spread is equal to those cuboids, then the spread needed for one whole waffle is 18 cm cubed. This is because we only put the spread on one side of the waffle, which is a semicircle of the circle. So those pictures are like an examples of spread used, like strawberry jam, honey, and also chocolate syrup. So that's all from me.
Assalamualaikum warahmatullahi wabarakatuh. Let's continue with our next topic, which is dome of visions. The dome of visions was designed by Danish architects Christopher Talbot and Benny Jobson, and also constructed by NCC. It is located in Copenhagen, Denmark, and it is an ongoing project. And the project year was in 2013. Next, like I said before, Dome of Visions is an ongoing project, and the Dome of Visions Copenhagen is the first project they held. They have a garden. They expanded to raised bed for vegetables and also birds, and also for irrigation system. The structure itself is mobile and will be moved to several places in Denmark throughout the year of 2013, which is the year of the project. So, by the end of May 2013, if I'm not mistaken, they moved the dome from Copenhagen to Aarhus, and it will be returned to Copenhagen again by the late summer or early fall.
So hi, my name is Anis, and last but not least, I will present to you a calculation of dome. For your information, the shape of dome is hemisphere. So we can conclude the height and radius is equal to 10.5 meter. So we calculate the surface area, the area and volume for the dome. The first one is surface area. We use the formula 2 pi r2, and we just need to substitute the radius into the formula, and we got 692.72 meter square. And the second one, we calculate the area, and we use the formula pi r2. Same like before, we just need to substitute the information, and we got 346.4 meter square. And the last one is volume. We use the formula 4/3 multiplied by pi r cube, but we need to multiply by 1/2 because the dome is hemisphere, right? So we need to use 1/2, and yeah, just same like before, we just need to substitute the information, and we got the volume of dome is 24.5 meters squared. So just that for me. Thank you. This is additional specification for the dome. The information about area, height and surface area.
So that's all from our group. Let's look for the conclusion. So in short, it is vital for us to learn geometry because everything we see every day, from the architectural building to our foods, are related to geometry. The perfect amount from the calculations of geometry gives us best results in making something. That's all from our group. Thank you very much.